Hi guys, welcome back to my YouTube channel. I'm here, Engineer Cinco from CLNP. And our topic for today regarding rectangular parallelepiped under solid mensuration. Last time we have studied uh, cube geometry. So now this is the second topic for solid mensuration or solid geometry, which is called rectangular parallelepiped. So, by the way guys, if you are first time in my channel, kindly like, share, and subscribe our YouTube channel para mas marami pa kaming may share na videos regarding some mathematics. Okay? So, continue today. Um, I have here a diagram related to rectangular parallelepiped. Okay? Having dimension of length. Okay? This one, length, and the width, including the height. And one more thing, there's also an internal diagonal inside the rectangular parallelepiped, okay, which is D. So today we will study regarding this geometry on how to find the volume for this parallelepiped. Okay. So first, volume of rectangular is equal to the product of three dimensions, which means the length times the width, okay, times the height, regardless of dimensions, any unit you like, either centimeter, inches, in feet, or in meters, whatsoever. Okay, so that is the first property of rectangular parallelepiped, how to solve volume. Okay, the second is the how to solve the total surface area of the six faces, because as you can see guys, in this rectangular parallelepiped there are six faces, okay, these sides and the other one behind, okay, these sides, okay, and the bottom and the top. So there are six faces uh, for this rectangular parallelepiped. So the total surface will be twice the length and the width, okay, the product of length times width times 2, okay, plus, because there are two sides, okay, for this face, the bottom face, okay, including the top, so two faces are there, so that's why we multiply it by 2, length times width, okay, plus twice the product of width times the height, okay, width times the height, because there are two sides here, this one and the other one, okay, plus again twice the product of the length times the height, so these sides guys, okay, and the other one, okay. So to simplify this expression, as you can see here, we have a common factor of 2, okay. So expressing this 2, okay, 2 times the product of length times width plus the product of width times height plus the product of length times height, okay. So the sum of these three dimensions times 2, it will become the total surface of the rectangular parallelepiped or the six faces. And last thing here is we have the internal diagonal of the rectangular or a box D. So how to find the length of this diagonal? Okay, the equation for this diagonal is equal to the square root of the sum of the square of its dimensions. Okay, length to the powers 2 or length squared, okay, plus the width into squared and the height into squared. So summation for this one, and then you have to square and square root so that you will find the diagonal length of the rectangular parallelepiped, where L is the length, W width, H is the height, and D is the internal diagonal. Okay guys, so before I'm going to give an example, um, I hope you have understand some properties of this rectangular parallelepiped, okay? Okay guys, as I mentioned earlier, I am giving you some example word problem related to this rectangular or parallelepiped under solid mensuration. So I have here a problem. Number one, it states that how many square meters, okay, square meters of steel plate, okay, steel plate needed to build a rectangular tank with open top. Take note guys, the rectangular tank is an open top, okay, open top. Now the length and width of the tank is 10 meters and 5 meters respectively. And also it can accommodate around 200 cubic meters of water. So guys, as you can see in this problem, what is the requirement? The requirement is how many square meter or the area, how many area of or square meter of steel plate required, okay, to fabricate a steel tank. It's having a rectangular type. Okay, so solution guys. The tank is a rectangular parallelepiped type with an open top. Okay, it's a water tank, water steel tank. Okay, so let me draw the geometry. Okay, the rectangular tank. Okay. Okay. So if this is the tank, okay, open top, as mentioned in the problem, okay, open top, and this is the length, okay, and this is the width, and this is the height, okay, or h. So in order to find the total area required to build a rectangular tank is we need to find first the height, since it is lacking in this problem, okay. The given is only the length and the width, but we need to find the height of the tank first in order to calculate the total area, okay, knowing the volume of water is equal to volume of the tank also. So solving first, okay, solving first the height, the tank height, okay, tank height, h, okay, terms of meters, because the unit is in terms of meters, okay? So what is the formula for volume of a rectangular parallelepiped? As we studied earlier, volume is equal to length times the width, okay, times the height, right? So knowing the total volume of water, we can equate this equation by substituting the total volume of water in this, okay, 200 cubic meter, okay, is equal to how much the length? It was given here guys 10 meters and the width is 5 meters, okay, 10 meters, okay, times the width is 5 meters, okay, times the height, which is unknown, okay. Now to simplify this expression, 200 is equal to 10 times 5 is 50. Okay? Times the height. Okay? Now, to find the height, we need to bring down 50. Okay? So, height of the tank will be is equal to 4 meters. Right? 200 divided by 50 is 4 meters. Okay? Now, we have already the height of the tank. So, all the dimensions are complete. Length, the width, and the height are already known. Now, in order to solve the area or the total area in square meter for making the rectangular tank, as we studied earlier, okay, then solving the total, okay, area, surface area, okay, total surface area of the tank, except for the open top, except for the top because it is an open, okay, except the top, except the top, okay, since it is open. So total area total area is equal to length times the width. Okay, the length times the width. This is the area for the bottom. So only one, guys, because the top is open, so we will not include for the top. Okay, plus the length times the width times the height, since there are two sides. Okay, so it will be 2 width times the height. Okay, plus the other sides. Okay, twice the length times the height. Okay, guys, we have already the length, the width, and the height. So substituting those values, total area is equal to, what's the length? 10 meters. Okay. How about the width? How much the width is 5 meters. Okay. Plus twice, how much the width? 5 meters. Okay. How about the height? Height is already calculated here, 4 meters. Okay. Plus twice the product of length times height. What is the length? 10 meters. Okay. Length is 10 meters. Okay. Times the height is 4 meters. Okay, guys. So to simplify further this expression, let me continue here. Okay. Total area is equal to 10 times 5 is 50. Okay. Plus 2 times 5, 10 times 4, 40. Okay. Plus 2 times 10, 20 times 4, 80. Okay. So the sum of all these three values is equal to 170 square meter of steel plate. Steel plate required, okay, to build a steel tank. Okay. So this is the final answer for this particular problem related to rectangular parallelepiped under solid mensurations. Okay guys, so I hope you understand this simple problem. Okay, and I'm hoping also that it will be helpful to those students who are studying in grade 9 students, or even in college, who are taking some engineering courses. Okay, solid mensuration. So again guys, kindly share, like, and don't forget to subscribe our channel. Okay, so again, thank you for watching, and have a nice day.